There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia subduction zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gurwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. The recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We've observed such changes for the first time, but they're likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. Now, the inner core of our planet, located about 3,100 miles below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. Now, this outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we really didn't understand its impact on the inner core. But now, the new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core, and that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we really don't notice these changes, but they could influence Earth's overall rotation and length of days. The study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It also allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped, and this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists can also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of our core. But what would happen if Earth's core suddenly stopped spinning altogether? Well, it's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movements, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers or on the floor. The planet would experience something similar, but with tectonic plates. Ew. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the Sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime or ever. So for now, we're safe. But to truly understand Earth, you need to go 4,000 miles beneath our feet. Earth has four main layers, from the very center to the surface: the inner core, outer core, mantle, and crust. Now, except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 7.5 miles, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 758 miles in radius, which is about 3/4 the size of the Moon. It sits about 4,000 to 3,200 miles below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 9,800 degrees Fahrenheit. It's like the surface of the Sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests that there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 3,200 to 1,800 miles beneath the surface. The heat here comes mostly from the radioactive decay of elements, like uranium and thorium, causing the liquid to churn in massive, turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer. stretching almost 1,800 miles deep. It starts just around 19 miles beneath the surface. Made of iron, magnesium, and silicon, it's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 62 to 124 miles underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 124 miles. But rarer, super-deep diamonds may form as deep as 435 miles. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it's the outermost layer of Earth. It's about 25 miles deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
See this weird grayish lump lying on the ground and steaming? Well, what are you waiting for? Run as fast as you can. It can burst right into your face at any moment, leading to horrifying consequences. A disaster is unfolding in front of your eyes. At first, the ground starts trembling. A deep rumbling sound echoed through the valley. Then, boom, the volcano explodes, hurling glowing rocks high into the sky. Among them is a blob of molten rock, fresh from the Earth's fiery depths. As it's soaring, the blob begins to change. The cold air wraps around it, hardening its outer layer, while the inside remains hot and gooey. Some of its neighbors are different. Some have gas bubbles trapped inside. Others have solid rock cores, and a few stretch into long, twisting ribbons. The biggest of these flying blobs are as large as a small car. For 10 long seconds, the lava blob is flying and twisting and tumbling. Below, people begin to realize the extent of the danger and start scattering. It's useless. Flying blobs can travel for miles, up to 6 miles away to be precise. Then the moment comes. The lava blob slams into the ground. Some of its smaller companions have cooled completely and landed with a thud, but this one is still burning inside a crystalline container called a bleb. As it strikes the Earth, its hard shell cracks and molten lava oozes out, sizzling and steaming, spreading out like a giant fiery pancake. The eruption is past, but the danger remains. Lava bombs, though fascinating, are among the most dangerous tricks of a volcano. The insides of the biggest blobs remain blazing hot, still bubbling with energy. They're not just warm, the temperature inside reaches hundreds of degrees. If one of these fiery projectiles struck a person, it would crush them instantly. Even worse, lava bombs can blow apart or cause secondary explosions in 2 cases. If the lava bomb has volcanic gases, like water vapor, CO2, or sulfur gases inside, rapid cooling can trap them. When pressure builds up, it can cause the bomb to burst. Or, if a hot lava bomb lands in water or ice, the sudden temperature change can create steam explosions, sending debris flying. Lava blebs come in different shapes, depending on how fluid the magma was when it was ejected. Their forms are also shaped by how they travel through the air and how they land. Ribbon blebs form when very fluid magma is thrown out in long, stretchy blobs. As these break apart in midair, they create thin ribbon-like fragments that land intact. These blebs often have fluted textures and small air pockets inside. Spherical blebs also come from highly fluid magma, but instead of forming ribbons, they're shaped by surface tension, which pulls them into nearly perfect spheres as they cool. Spindle or almond-shaped lava blebs start off similarly to spherical ones, but as they spin through the air, they stretch into elongated football-like shapes. One size usually ends up smoother than the other, showing how it moved when it fell. Cowpie blebs, yep, the real name for them, form when very liquid lava doesn't cool before hitting the ground. Instead of solidifying in the air, it lands while still molten and flattens on impact, spreading out in irregular roundish shapes that resemble, cow patties. There are also bread crust blebs that occur when the outer layer of a lava bomb hardens during flight while the inside remains hot. As the interior expands, it cracks the hardened shell, giving it a texture similar to the crust of a loaf of bread. Cored lava bombs have a hardened shell surrounding an inner core made of older volcanic rock, pieces from an earlier eruption, or even fragments of the surrounding landscape. Whatever shape a lava blob takes, you should watch out for one during a volcanic eruption, even if you're miles away from the epicenter. But lava blebs aren't the only danger you should watch for when wandering around volcanoes. Sometimes, when small drops of lava are thrown from a volcano, they can stretch into thin, elongated shapes as they cool. If they form small teardrop-like shapes, they're called Pele's tears, after the Hawaiian volcano and fire deity. If they become longer, thinner strands, they're known as Pele's hair. In this case, you can notice something that looks like golden mats of fine hair covering the ground. These aren't strands of human or animal hair, but delicate threads of volcanic glass. They form when gas bubbles in lava burst, stretching the molten rock into long hair-like fibers. Pele's hair can be incredibly thin, sometimes just 1 micron thick. But at the same time, they can reach up to a couple of feet in length. They are so lightweight that the wind can easily carry them through the air. Later, they settle in low-lying areas, sometimes piling up in thick layers. Now, despite their delicate appearance, these strands are actually tiny pieces of glass. They are sharp and brittle, and if they get on the skin, they can cause irritation. If they get into the eyes, they can be even more dangerous. That's why it's very important to be cautious when around Pele's hair. Now imagine a tidal wave of fire and ash racing down a mountain with unstoppable force. This is a pyroclastic flow, a fast-moving surge of scorching gases and shattered rock that buries everything in its path. These flows can stretch for miles, moving as fast as a racing car and reaching temperatures hot enough to melt metal, up to 1800 degrees Fahrenheit. Pyroclastic flows strike without warning. The collapse of an erupting volcano's towering ash column or a lava dome, a massive plug of hardened lava sitting at the volcano's mouth, can easily trigger one. The moment it gives way, the fiery avalanche is unleashed, rolling down the slopes with terrifying speed, vaporizing forests, flattening villages, and incinerating anything caught in its path. There is no outrunning a pyroclastic flow. It is the most fatal force a volcano can unleash, responsible for claiming over 90,000 lives in the past 400 years. That's 1/3 of all volcanic fatalities. Not only do these flows burn, crush, and suffocate, but they also destroy buildings, bridges, and anything human-made. While scientists can predict the most likely paths, usually along valleys, history has shown that powerful flows can jump ridges, sweep over hills, and strike areas we once thought were safe. Volcanic lightning isn't as dangerous as a pyroclastic flow, but it's a breathtaking view. It forms only in the thick ash-filled clouds that erupt from certain volcanoes. These towering columns, called volcanic plumes, shoot up into the sky when a volcano releases massive amounts of ash. Not all volcanoes create these plumes. That's why volcanic lightning is rare. For example, the volcanoes in Hawaii mostly erupt with flowing lava rather than thick clouds of ash, so they almost never produce volcanic lightning. Now look at these tiny ash particles. Before an eruption, they're squeezed together inside the volcano under extreme pressure. But when they burst into the open air, they collide and rub against each other in a process known as friction. This friction charges the particles, just like when you rub a balloon on your hair. As these charged particles rise into the air, they start to separate. Positive charges move one way, and negative charges move in a different direction. When the difference in charge becomes too great, the energy bursts free as a lightning bolt, cutting through the volcanic plume. Some of the most devastating consequences of a volcanic eruption are lahars. A lahar is a powerful, fast-moving river of mud, ash, and rock that rushes down the slopes of a volcano, destroying everything in front of it. These terrifying mud flows form when heavy rains mix with loose volcanic debris. When lahars sometimes happen during an eruption, they can also strike without warning. This makes them especially dangerous. Like pyroclastic flows, lahars move fast, sometimes traveling hundreds of miles. They can bury entire towns, sweep away bridges, and wipe out roads, leaving behind a deep layer of mud and rock. One of the most devastating lahar disasters happened in Colombia in 1985 when the Nevado del Ruiz volcano unleashed a mudflow that buried the town of Armero, taking the lives of over 23,000 people. Another tragic event occurred in the 1990s when lahars and pyroclastic flows from the Soufriere Hills volcano wiped out the capital city of Plymouth, causing $500 million in damage. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid fault, putting even more strain on the nearby Reelfoot fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare. So for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and meconium. a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands.
Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue. Much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer, They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on 2 tectonic plates. The Nubian one carries most of the continent. The smaller Somali plate holds the Horn of Africa. The crevice in Kenya appeared in the rift valley between these 2 plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into 2. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be 2 African subcontinents. They will be separated by a body of water that will become our planet's 6th ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. The world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The 2 act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only 2 places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The two continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed a billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the Earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land: Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future.
So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with 1 neutron instead of the usual 2. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3. storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's Central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the Central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding Central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the Central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the Central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Kolkata and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich, and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya, first in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The 2 are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into 2 continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
An hour after people disappear, most urban areas will be left empty and quiet. Perhaps the sound of wind, falling leaves, or other natural sounds previously drowned out by city noise and traffic will be heard. The subways of many cities are protected from groundwater by a system of pumps. If there are no people to monitor such systems, most subways will flood within 36 hours. Due to malfunctions, sewage treatment plants will stop working, leading to pollution of rivers and lakes with wastewater. The water pipes in Detroit will become unusable, leading to the flooding of the city. Food in refrigerators will spoil. Raccoons and wolves will inhabit abandoned human homes. Major airports will be covered in rust and overgrown with ivy. Cruise ships in Alaska will sink under the weight of ice that accumulates on them. Lions from the San Diego Zoo will gradually escape, emboldened by the power outage of the electric fence around their enclosures. More and more black cats will appear on the streets of Rome and the Vatican. Rats and mice will consume all edible reserves and leave the cities. Plants will begin to grow in cracks in streets, highways, sidewalks, and buildings. More and more animals will notice the absence of people and flock to the cities. International Space Station will gradually decrease. Since no one will correct its orbit, the station will eventually fall to Earth and burn up. Along with it, digitized samples of human DNA will perish. A large part of the city's territory will be covered with a vegetation of lianas, grasses, and tree seedlings. The Red Square in Moscow will have a layer of soil and thick grasses growing, making the square completely green. Despite high levels of radiation, animal populations are increasing in abandoned areas. Plants have grown in many houses and buildings. Seawater will flood cities that were once drained by artificial drainage systems, such as London and Amsterdam. Satellites will begin to fall to Earth. Since no one maintained their speed of movement, they slowly approached Earth and eventually fell to the planet's surface. Wolves now roam freely around the Brandenburg Gate in Berlin, and wild boars will be seen in Paris. Human speech will be preserved in rare words that parrots have memorized during their years of living with humans. Snakes will not only reproduce at incredible rates, but also grow much larger in size. Their main prey will be rodents that have multiplied in the first years after humans disappeared. Many human-made structures will collapse within 100 years, primarily those with a large number of steel elements. Fruit Christmas cakes, thanks to their alcohol coating, will not only retain their appearance but also freshness. Most buildings will be overtaken by plants and animals, and the city will resemble more of a wild nature landscape. The period of nuclear fuel decay will come to an end, and as a result, dead zones around the ruins of nuclear power plants will once again become habitable. The last parrots that spoke human language may go extinct since they memorized human speech, but it is simply not necessary for their survival in the wild. All modern carriers of information that preserve human culture, laser discs, photographic film, paper, and the like, will turn to dust. Rebar inside concrete buildings, which are more durable than steel ones, will expand 3 times due to rust, causing the destruction of concrete structures. Most modern cities will be covered by a green blanket, and collapsed skyscrapers and buildings will become new hills. Manhattan will return to its former state before human settlement, with numerous streams and lakes. There will be almost no evidence of the existence of human civilization. Only powerful stone buildings that rely solely on the force of gravity will survive, such as Notre Dame de Paris. Of the products that existed during human civilization, only honey, especially in clay pots, and oil in wooden barrels, will be well preserved. Only a few stone structures will survive, including the pyramids in Giza and the Sphinx, almost entirely buried in the sands of the desert, and fragments of the Great Wall of China. By this time, a new ice age will begin on Earth. It is expected that the KEO satellite will enter the atmosphere by this time. Various pieces of space debris will collide with it during its descent, but this will not destroy the satellite. Eventually, it will fall into the waters of the world ocean. Remnants of spacecraft and satellite debris will float through space as the only reminder of human civilization.
On September 23, 1880, a guy named David Lang was just strolling through his fields in Tennessee when, out of nowhere, he vanished into thin air. There was nothing around him to trip over, just wide open land with no trees, fences, or even a rock in sight. His wife and kids were watching from their windows as he walked home, and two guys in a buggy also saw him disappear. So, panic set in immediately. Could it be a sudden hidden sinkhole that swallowed him? But when the family rushed to the spot, the ground was solid, with no holes and not a trace of where he could have gone. His wife had to be taken inside while search parties combed the field. But there was nothing. No footprints, no disturbed soil, no answers. Days turned into weeks, and weeks into months. But no one saw or heard from David Lang until a year later. His young daughter, who couldn't let go of him, stood in the exact spot where he had disappeared and called out to him. And then it happened.
Help me.
A faint, desperate voice echoed from nowhere. Help me! She ran for her mother, who also heard the eerie cry for help.
Help me.
For days, they kept returning to the spot, listening to the ghostly whispers of David Lang. They were growing weaker and weaker until there was complete silence. Did some mysterious portal between dimensions open? And did David step inside? And here's where it gets even stranger. Some say the grass in that spot grew unnaturally thick and lush, but no insects or animals would go near it. Others swear that nothing ever grew there at all. It turned into a barren patch of land forever cursed. Whatever the truth is, David Lang was never seen again, and some people still avoid visiting the field. But don't worry, you don't have to avoid the area, as the story is most definitely just an urban legend. It looks like the whole story might have come from one well-known hoaxer from the 1880s, who probably invented the David Lang story as part of a lying contest. Over time, the tale became a piece of local legend. Another mystical disappearance supposedly took place in Prussia. On November 25, 1809, in Perleberg, a man walked into an inn, ordered dinner, and vanished into thin air. It was Benjamin Bathurst, a British diplomat traveling under the alias Baron de Caux. He was running away from Napoleon's spies. After writing for hours in a private room in the White Swan Inn, he stepped out and headed for his carriage. But when his assistant arrived moments later, Bathurst was gone. News of his disappearance didn't reach England for weeks, and when it did, his wife, Philida Bathurst, rushed to Prussia. Together with a search party, she was scouring a nearby river and every corner of Perleberg. Then, strange clues began appearing. Bathurst's expensive fur coat, worth a fortune, turned up hidden in a stable. Weeks later, two old women scavenging in the woods, miles from Perleberg, found his pantaloons. A stablehand at the White Swan Inn, August Schmidt, became a prime suspect. His mother had stolen Bathurst's coat, and a woman from a nearby coffee house swore that Schmidt had chased after Bathurst that night. So, he probably took the life of the British guest. But as a lump sum was offered as a reward, false leads and rumors flooded in, and it was harder and harder to learn the truth. Philida Bathurst refused to give up and went to Napoleon Bonaparte himself, hoping to hear some answers, but he denied that it had to do with him. To this day, Benjamin Bathurst's fate remains a chilling mystery. Writer Mike Dash, who did his own investigation of this case in 1990, came to the conclusion that people were just adding mysterious details to it over the years. In reality, someone just took Benjamin's life that night. Over a century after Benjamin's disappearance, in a completely different part of the world, a man named James Tedford stepped onto a bus, took his seat, and then somehow vanished into thin air before reaching his destination. It happened on December 1st, 1949, when he was traveling back to Bennington, Vermont after visiting his family. Witnesses on the bus swear he was there the entire time, sleeping peacefully in his seat. But when the bus reached Bennington, his suitcase, his unfolded map, and even his bus ticket were still on the seat, but Tedford was simply gone. The last time anyone saw him alive or not was at 4 p.m. Remember this time. This eerie disappearance wasn't the first or the last strange event in what locals call the Bennington Triangle. This area is famous for unexplained vanishings, sort of like the Bermuda Triangle on the ground. Between 1949 and 1950, multiple people disappeared under bizarre circumstances. Tedford went missing almost exactly 3 years after a young woman named Paula Weldon was last seen walking near the same area. It was also December 1st, around 4 p.m., when 18-year-old Paula stepped out of her dorm at Bennington College. She told her roommates she was heading for a hike on the Long Trail. A local man later said he gave Paula a ride and dropped her off a few miles from the trail. She was dressed in a bright red coat. Paula spoke with a few hikers before venturing into the wilderness alone, and then she was gone. The police and her devastated father were really trying hard to find her for 4 weeks, but failed. Whispers soon spread that she had just run away. Paula's father was sure that she had a secret boyfriend, a man who either lured her away or took her life. But there was no evidence to prove this theory. The local tribe believed that Glastonbury Mountain, which lies in the heart of the Bennington Triangle, was cursed and full of restless spirits. So Bigfoot or some unknown force could have caught those missing people. Each of them disappeared in the late afternoon, between 3 and 4 p.m. 2 of them were wearing red, and not a single body was ever found. Some believe it was one person taking lives in the area, but the targets were too different in age and gender to fit one pattern. Others say it all happened because the terrain here is pretty rough and the winds are strange and severe. But winds can't possibly take a person out of a moving bus, so the mystery lives on. On July 18, 2007, Barbara Bolick set out on a walk down her favorite trail in Montana's Bear Creek Overlook. She knew the trail like the back of her hand, and she had a backpack filled with food, water, and even something to protect herself from wild animals. She was hiking with her family guest, Jim Ramaker. As he later remembered, the hike was going just fine when they stopped for a bite and met 2 young men. After parting ways with them, Barbara just walked 20 or 30 feet ahead of Jim on the trail. Jim paused for less than a minute. Then he looked up and found no traces of Barbara. He scoured the trail, but he couldn't find the woman, her backpack, or even footprints leading away. He rushed to the nearest people he could find, construction workers at the trailhead. They hadn't seen her either. Rescue teams with dogs and helicopters investigated every possible hiding spot, but they found nothing. And dogs couldn't even pick up Barbara's scent. Now it wasn't clear if she had been there all day at all. If a wild animal had gone after her, there would be signs and sounds of struggle. She could have fallen into a crevice, but Barbara was afraid of heights and super careful around them. And she wouldn't just run away from her family, as her passport, ID, and her beloved pets remained at home. Her disappearance remains a mystery. In the ice caves of Mount Rainier in the United States, vibrant blues and whites form breathtaking ice sculptures that sparkle like precious gems. But don't get too close. These delicate formations are constantly at risk of collapse. As temperatures rise, ice chunks and flakes, some the size of a small car, break loose and fall from the cave ceiling. Explorers also face the risk of hypothermia, with freezing air inside and even colder meltwater flowing from the snowfield. The volume of meltwater increases as the day heats up, making the caves even riskier in the afternoon. If you dive into this strange pond in Norway, known as Plura, and swim around for around 1/3 of a mile, you will emerge into a long, colorful cave where limestone and marble formations form narrow and edgy passageways. If you are an okay diver, who does it just for fun, you can end your exploration there. But this cave system is the deepest in Northern Europe, so highly trained and experienced divers can continue exploring the course, which quickly plunges much deeper through pitch black, ice-cold water, becoming narrow and difficult. In winter, temperatures drop to around 36 degrees Fahrenheit. Sadly, tragic incidents have marked this cave's history, as lost divers have faced perilous retrieval efforts. Jacob's Well in Texas looks like a calm 12-foot swimming hole, inviting and refreshing. Yet, what lies beneath is a treacherous sinkhole leading to a hidden underwater cave system. The dark, secretive depths beneath the placid water descend vertically for about 30 feet, then continue downward at an angle through a series of silted chambers separated by narrow restrictions, finally reaching an average depth of 120 feet, which is about the height of a Ferris wheel. Despite its pretty appearance, the well claimed 9 lives between the 1960s and the 1980s, but some people speculate that the actual number could be higher. This is why these dark, secretive depths are still known as some of the most dangerous diving locations in the United States. As we dive deeper into the Earth, we find ourselves in Verkhovnica Cave in Georgia, known for being the deepest cave in the world. It is over 7,000 feet deep, plunging into the unknown, where there is a real risk of deadly floods from underground sources. At the deepest level you can reach, there's a stunning turquoise lake surrounded by jet black limestone. It is described as a beautiful yet eerie spot that can quickly turn into a scenario where you need to fight for survival. When storms and thunder hit, the roar inside the cave is almost deafening, and the water floods rise really fast. When this happens, explorers cannot afford to wait. They must find a way out immediately. The thing is, caves and storms together are a seriously dangerous mix. Take, for example, the event that occurred in 2018 that had the whole world glued to the news. 12 boys from a junior soccer team went exploring in Thailand's Chiang Rai province with their coach. They raced their bicycles up into the forested hills to reach the Tam Long Cave. In high spirits, they clambered into the cave with just their torches, planning to stay for only about an hour. But they didn't emerge until 2 weeks later. That's because right after they entered there, heavy rainfall began, partially flooding the cave system, blocking their way out, and trapping them deep inside. This is how the world learned about the real dangers of the Tam Long Cave. The Kidam Caves, located in Mount Elgon National Park in Kenya, is considered one of the most dangerous caves in the world. The cavern walls are covered in scuffs and marks that appear to have been made by miners searching for gems or gold. But later, it was discovered that those strange marks were actually made by elephants that go inside and mine the rock, seeking its sodium-rich salts. Although it is interesting, that's not the reason the cave is so frightening. It turns out these caves have a long history of being a breeding ground for some of the most fatal viruses in human history. Just to be safe, it's best to stay far away from there. In Mexico, the Nika mine offers a jaw-dropping spectacle of gigantic crystals towering over visitors. This otherworldly landscape is more than just a visual marvel. It's also bathed in extreme heat, with temperatures rising as high as 136 degrees Fahrenheit. Additionally, the air in the cave has 90 to 99% humidity, making the environment feel even more unbearably hot.
But before you start making travel plans to visit this amazing natural site, keep in mind that this cave is completely off limits to tourists. Only scientists with special permission can enter, and they must wear protective gear. Our next stop is in New Zealand, where you can find the Cathedral Cave, which is actually two connected limestone sea caves located on Waipati Beach. With 600 feet of tunnels reaching impressive heights of 98 feet, these caves are among the most remarkable sea cave complexes in the world. And they were formed after waves hit the same spot over thousands of years. The caves earned their name thanks to their acoustics, which are so good that they remind of those in a cathedral. However, you cannot test your singing skills at just any time, as it's only safe to visit during low tide. To avoid danger, visitors are only allowed when weather, sea swell, and tides are favorable. If you're not a fan of bats, you should definitely stay far away from Bracken Cave, located in Texas. During the summer, this dark hole becomes home to the largest colony of bats in the world. I'm talking about around 20 million Mexican free-tailed bats roosting there from March to October. Those people who are brave enough to approach say it's like watching a ballet as millions of bats emerge from the cave in synchronized waves, never once bumping into one another. If you listen closely, you can hear their wings flapping, which people describe as sounding like steady, gently falling rain. Now we arrive at Cueva de los Teos, which is known for an enigma that has intrigued explorers for decades. Located in the Andean jungle of southeastern Ecuador, this cave can only be accessed through a narrow 230-foot vertical drop known as the chimney. Inside, explorers find a labyrinth world of chambers the size of large buildings, connected by narrow galleries and impressive halls, some of which are pierced by jagged stalactites and stalagmites. If that isn't enough to make your heart race, wait. Cueva de los Teos is rumored to contain ancient artifacts and secrets from civilizations long past. Some say it holds a metal library with golden plates engraved with a previously unknown history of humankind. Others believe that the tunnels are too perfect to be natural, suggesting they must have been created by ancient people, possibly with the help of extraterrestrial technology. These rumors have spurred many expeditions to the cave, including one led by Neil Armstrong. Yes, that Neil Armstrong, who sought to uncover its mysteries. To this day, however, the cave has kept its secrets well hidden. Just like Cueva de los Teos, the final cave on our list isn't particularly dangerous, but it'll certainly send chills down your spine. I mean, look at this stone wall, completely covered by hand shapes. What seems like something out of a horror movie is actually the Cueva de los Manos in Argentina. The name means Cave of the Hands in English. And getting to these prehistoric hand paintings, made about 13,000 years ago, is no small feat. The most adventurous travelers take a 1.5-hour hike through rugged terrain to reach it. But the moment explorers step inside, they are greeted by this incredible artwork from ancient times. It is believed that there are around 800 hands inside this cave, with palms of various sizes, some small, others long and thin, indicating that in addition to men, the prints belong to women and children. Their authenticity is unquestionable, which makes it all much more interesting.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, uh-oh, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.